What if everything we think we know about the origins of intelligent life is wrong? Picture a universe where civilizations rose and fell billions of years before Earth even formed, where advanced beings walked among the stars while our planet was still a swirling cloud of cosmic dust. This isn't science fiction. It's a possibility that some of the brightest minds in astrophysics and ancient history are taking seriously. Today, we're diving deep into 30 astonishing theories about the universe's first civilizations, ideas that challenge the very foundations of what we believe about our place in the cosmos. Think about the scale of time for a moment. The universe is nearly 14 billion years old, Earth just 4.5 billion. That means there's an almost unimaginable gap, 9.5 billion years, where life could have risen, thrived, and vanished countless times before our solar system even existed. Some researchers suggest that ancient star systems, long since gone dark, might have hosted societies far more advanced than ours. Others propose that remnants of these civilizations could still be out there, hidden in plain sight, encoded in the fabric of space itself. What's even more mind-bending is that we might not need to look to distant galaxies for clues. Right here in our own cosmic backyard, there are mysteries that defy conventional explanation: ancient structures on Earth, unexplained astronomical phenomena, even oddities in our own DNA, that some scientists argue could be the fingerprints of these lost civilizations. Over the next 30 theories, we'll explore the most compelling evidence, the boldest hypotheses, and the haunting question: if we're not the first, what happened to those who came before? Buckle up, this journey will stretch your imagination to its limits. The first theory takes us back to the beginning, or at least what we think was the beginning. Meet the Precursor Civilization Hypothesis, the idea that an ultra-advanced society may have thrived in the universe's infancy when conditions were radically different. Picture this, a cosmos just a few 100 million years old before Earth, before our Sun, even before most of the stars we see today. In that primordial era, these beings could have risen to mastery over energies and materials we can barely comprehend. Some theorists suggest they might have tapped into dark energy, the mysterious force accelerating the universe's expansion, using it as a power source or even a tool to reshape reality itself. We're talking about structures beyond anything humans have built: Dyson swarms encircling entire galaxies, quantum computers the size of solar systems, or even time-dilating engines that let them outlast the lifespan of stars. If they existed, traces of their technology might still linger: distortions in the cosmic microwave background, unexplained heat signatures in distant voids, or even strange geometric patterns etched into spacetime. This ties directly into the Fermi Paradox, the eerie silence of the universe. If life is common, why haven't we heard from anyone? One chilling answer: the precursors may have already come and gone. Perhaps they burned too bright, exhausting resources or triggering their own downfall. Or maybe they transcended into something beyond our perception, leaving behind only cryptic remnants. Either way, their absence could be the reason the cosmos feels so empty. And if we ever do find evidence of them, it might rewrite not just our history, but our future. What if the messages from ancient civilizations aren't hidden in ruins or artifacts, but woven into the very fabric of reality? Enter the second theory, quantum archaeologists. This mind-bending idea suggests that an ultra-advanced society didn't just leave behind physical traces, they encoded their knowledge into the quantum fluctuations of spacetime itself. Imagine a civilization so advanced they didn't carve their history into stone but imprinted it into the underlying structure of the universe, like cosmic Morse code written in the vibrations of particles. Recent studies have uncovered strange anomalies in quantum behavior, tiny fluctuations that don't quite match our predictions. Some physicists argue these could just be natural quirks of quantum mechanics, but others propose a far more radical explanation. These fluctuations might be deliberate signatures, a form of communication left behind by beings who mastered quantum physics millions or even billions of years before us. Think of it like finding fingerprints on a subatomic scale, except these fingerprints might contain entire libraries of information waiting to be decoded. The debate rages on whether these patterns are intentional or simply cosmic static. Skeptics point to Occam's razor, arguing that nature often creates complexity without purpose. But proponents counter that certain quantum irregularities appear suspiciously structured, almost like mathematical sequences or repeating waveforms. If true, it would mean the universe itself is a vast archaeological site, and we're only now developing the tools to dig. This theory also raises a haunting question. Why would a civilization choose such an abstract way to preserve itself? One possibility is that quantum encoding is the ultimate time capsule, immune to entropy, surviving supernova and black holes. Another darker thought, maybe they knew their physical existence was doomed, and this was their last act of defiance against oblivion. Whatever the truth, the idea forces us to rethink not just history but the nature of reality itself. If we ever learn to read these quantum inscriptions, the message could change everything. Now let's turn our attention to one of the most tantalizing possibilities, the theory that ancient civilizations may have left behind the ultimate calling card, Dyson spheres. These hypothetical megastructures, first proposed by physicist Freeman Dyson in the 1960s, are exactly what they sound like: artificial shells or swarms of orbiting solar collectors designed to harness the full energy output of a star. And here's where it gets eerie. Astronomers have already spotted stars in our galaxy that behave oddly. Their light flickers unpredictably. Their infrared signatures don't match natural models. And one in particular, KIC 8462852, better known as Tabby's star, has baffled scientists for years with its bizarre, irregular dimming. What if these anomalies aren't glitches in the data but the ghostly remains of ancient engineering projects? Imagine a civilization so advanced that it didn't just inhabit planets, it dismantled them, repurposing every ounce of material to construct colossal energy farms around its sun. Over millennia, these megastructures would decay, their once perfect symmetry crumbling into fragments. But even in ruins, they'd leave traces, unnatural heat signatures, erratic starlight patterns, and unexplained dips in brightness as debris drifts across the star's face. That's exactly what we see with Tabby's star, a cosmic mystery that refuses to fit neatly into any natural explanation. But the plot thickens. Recent sky surveys have uncovered dozens of similar stars scattered across the galaxy, each exhibiting strange, repeating dimming patterns. Some dim by as much as 20%, far more than any known planet could block. Others flicker in rhythmic sequences that defy the randomness of natural cosmic phenomena. Could these be the dying embers of a once thriving interstellar civilization? Or perhaps something even more unsettling, an automated network of energy harvesters, still operating long after their builders vanished. Critics argue that dust clouds or swarms of comets could explain these observations, and they're not wrong. Nature is full of surprises, but here's the kicker. The most advanced simulations struggle to replicate the precise dimming curves we've recorded, curves that, coincidentally, match what we'd expect from a partially dismantled Dyson swarm. It's as if the universe is whispering a riddle we're only beginning to understand. If even one of these anomalies turns out to be artificial, the implications are staggering. We may be staring at the graveyards of gods, and if that's true, the real question isn't just who built them, but what silenced them. But what if the universe's first civilizations didn't just harness stars but mastered the invisible? The fourth theory takes us into the shadowy realm of the dark matter architects. Imagine beings who didn't build with rock or metal, but with the mysterious substance that makes up 85% of the universe's mass, dark matter. Unlike ordinary matter, dark matter doesn't emit, absorb, or reflect light. It's utterly invisible to our telescopes, and yet gravitational effects prove it's out there, woven through galaxies like an unseen scaffold. Some physicists speculate that an ancient civilization could have evolved beyond the need for planets or stars, learning to structure their entire existence within dark matter's elusive folds. Think about it. If dark matter particles interact weakly with ordinary matter, a society based on them would be nearly undetectable to us. Their cities, their machines, even their bodies, if they had them, might exist in a parallel reality right alongside ours, invisible and intangible. We could be living in the ruins of their empire without ever realizing it. Recent theoretical papers have explored the staggering possibility of dark matter engineering. One study suggests that advanced beings might manipulate dark matter's gravitational influence to create stable megastructures, cosmic-scale lenses for focusing energy, or vast networks of communication relays spanning galaxies. These wouldn't look like anything we'd recognize. Instead of glowing alloys, their technology might consist of intricate gravitational distortions, bending spacetime itself into tools. The most tantalizing clue: astronomers have detected bizarre, unexplained structures in galactic halos, regions where dark matter is thought to cluster. Some exhibit gravitational anomalies that defy current models, as if vast, invisible masses are arranged in precise formations. Could these be the remnants of dark matter cities? Or perhaps the dormant machinery of a civilization that transcended the need for light? Skeptics argue that these anomalies could simply be quirks of cosmology, but the implications are too profound to ignore. If dark matter can be engineered, then the universe might be teeming with civilizations we'll never see, not because they're extinct, but because they operate on a frequency we're blind to. It's a humbling thought. The cosmos could be alive with intelligence hiding in plain darkness. And if that's true, our search for alien life might be looking in all the wrong places. The fifth theory turns our gaze not to the stars, but inward into the very building blocks of life itself. What if the spark that ignited Earth's first organisms wasn't random chance, but a deliberate act? This is the provocative idea behind the Panspermia engineers' hypothesis, that an ancient civilization didn't just exist, they spread life intentionally across the cosmos, and we might be their legacy. Take a closer look at our own genetic code. Hidden within the twisted ladder of DNA are baffling complexities that defy simple evolutionary explanations. Some sequences appear almost optimized, as if fine-tuned for rapid adaptation. Others resemble viral structures, raising the eerie possibility that life's blueprint wasn't just shaped by natural selection, it was designed. Nobel Prize-winning scientist Francis Crick, co-discoverer of DNA's structure, once floated this very idea. He called it directed panspermia, the notion that microorganisms could have been intentionally transported to Earth by an advanced intelligence, packed into durable capsules and fired across interstellar space like biological Morse code. The evidence doesn't stop there. Consider the sudden explosion of life during the Cambrian period, roughly 540 million years ago. Before this, Earth's organisms were simple, single-celled. Then, in what geologically amounts to a blink of an eye, complex life erupted in staggering diversity. Traditional evolutionary models struggle to account for this abrupt leap. But what if it wasn't a leap at all? What if it was an update, a pre-programmed genetic awakening triggered by environmental conditions, left behind by engineers who knew exactly when and where their seeds would flourish? Even more compelling are extremophiles, microbes thriving in conditions once thought impossible for life. Boiling hydrothermal vents, acidic pools, even the vacuum of space. Their resilience is oddly convenient for organisms supposedly hitching rides on asteroids, unless, of course, they were engineered for the journey. Recent experiments show certain bacteria can survive thousands of years in dormant states, shielded by nothing more than thin mineral crusts. Scale that up to cosmic timeframes, and the idea of life as an interstellar contagion starts to feel less like science fiction and more like a viable theory. Skeptics argue that invoking alien designers is a cop-out, a modern-day version of gods of the gaps, but proponents counter with a chilling observation. If Panspermia is real, it wouldn't just explain life's origins. It would imply a universe where intelligence isn't the exception but the rule. A universe where civilizations rise, mature, and then broadcast their essence into the void, turning barren worlds into incubators. And if that's true, the most profound question isn't whether we're alone, it's whether we're meant to follow in their footsteps. What if the ultimate library of the cosmos isn't hidden in ancient ruins or encoded in quantum vibrations, but trapped in the most destructive force in the universe? This is the spine-tingling premise of the black hole librarians' theory. Imagine a civilization so advanced they didn't just archive their knowledge in books or hard drives. They etched it into the swirling maelstrom of black hole accretion disks, where information could survive for billions of years, immune to cosmic decay. Here's how it might work. Black holes aren't just cosmic vacuum cleaners, they're incredibly dynamic systems. Matter spiraling into them forms a superheated disk glowing with intense radiation. According to pioneering work by physicist Stephen Hawking, black holes also emit faint energy Hawking radiation as they slowly evaporate. But here's the twist: that radiation isn't random. It carries subtle imprints of the black hole's history, like a fingerprint. An ultra-advanced society could have manipulated this process, imprinting data onto the radiation structure by carefully controlling how matter falls into the event horizon. Picture it as cosmic Morse code, written not with light or sound but with the very fabric of spacetime. Why choose such a bizarre storage system? 3 reasons. First, durability. Black holes outlast stars, galaxies, even protons. Second, security. The extreme gravity acts as a natural encryption system. Only beings with quantum technology could ever hope to decode it. Third, scalability. A single black hole could hold more information than every hard drive on Earth combined. Now for the eerie part. Astronomers have detected unusual patterns in the X-ray flickers of certain black holes. Subtle, repeating oscillations that don't match standard astrophysical models. Some researchers suggest these could be natural turbulence, but others whisper a far wilder idea. What if we're seeing fragments of an alien Encyclopedia Galactica pulsing faintly across the eons? The catch: decoding this data would require technology we don't yet possess, quantum computers advanced enough to untangle information scrambled by relativistic effects. But if we ever crack that puzzle, the rewards would be unimaginable. We might gain access to the cumulative knowledge of a species that mastered physics millions of years before Earth formed. Their art, their science, their warnings, or perhaps their final confession locked in gravity's unbreakable vault. This theory forces us to confront a profound question. If civilizations can encode their essence into the most hostile environments imaginable, how many other cosmic wonders might secretly be messages in bottles waiting for us to learn the language of the universe itself? Could our distant descendants be the architects of the cosmos itself? The seventh theory plunges us into one of the most controversial ideas in cosmology: the possibility that time-traveling humans or other beings from the far future looped back to shape the universe's infancy. It sounds like pure science fiction, but when you examine recent astronomical discoveries and cutting-edge physics, the lines between fantasy and reality start to blur. Take the James Webb Space Telescope's baffling observations of so-called impossible galaxies, enormous fully formed structures dating back to just 300 million years after the Big Bang. According to mainstream models, these galaxies shouldn't exist. They're too massive, too mature, appearing as if they've had billions of years to evolve when the universe was barely a toddler. Could this be evidence of intervention? Imagine a scenario where a civilization masters time travel, journeys back to the cosmic dawn and jumpstarts galactic formation, either accidentally or deliberately, leaving behind anachronistic fingerprints in the process. Theoretical physicist Igor Novikov's self-consistency principle suggests time travel might be possible without paradoxes, as long as all actions taken in the past were already part of history. Picture this: what we perceive as the natural development of the cosmos could actually be the result of countless subtle manipulations by time-hopping engineers. They wouldn't need to build pyramids or leave obvious ruins, just tweak gravitational constants or seed early star formation, creating conditions that later enable their own existence. A bootstrap paradox written across 13 billion years, critics argue this veers into nonsensical speculation, and they're not wrong to demand extraordinary evidence. But consider the alternative explanations for those impossible galaxies. Maybe dark matter behaved differently in the early universe. Maybe our understanding of galaxy formation is fundamentally flawed. Or maybe, just maybe, we're seeing the handiwork of entities who treated causality as a suggestion rather than a law. The implications are staggering. If true, it would mean the universe isn't just older than we thought, it's far weirder. The first civilizations might not be alien at all, but our own descendants playing a cosmic game of chess with time itself. And if they succeeded in altering the past to ensure their future, what does that say about free will? About destiny? We might be living in a universe where history is still being written by travelers from a future we've yet to reach. We often assume life needs a planet, some solid ground, liquid water, organic molecules. But what if the universe's first thinkers weren't creatures of flesh and bone, but beings sculpted from fire and magnetic fields? The eighth theory shatters that assumption entirely: plasma-based life forms. Imagine intelligence born not in oceans or on rocky worlds, but in the searing hearts of stars or the vast, turbulent nebulae where stars are born. Plasma, the fourth state of matter, makes up 99% of the visible universe. It's ionized gas, atoms stripped of their electrons, swirling in complex structures governed by electromagnetic forces. In the scorching atmospheres of stars or the magnetic whirlpools of young galaxies, plasma can form astonishingly intricate shapes, filaments, double layers, even self-sustaining loops that behave almost like primitive neural networks. Some physicists speculate that under the right conditions, these structures might achieve something akin to consciousness, not through chemistry like our brains, but through the dynamic interplay of charged particles and cosmic-scale currents. The idea isn't as far-fetched as it sounds. Lab experiments with plasma have shown eerie behaviors, self-organizing patterns that mimic simple life, stable configurations that remember previous states, even spontaneous symmetry breaking, a hallmark of complex systems. Scale this up to stellar proportions, and you could have entities as vast as solar systems, their thoughts unfolding in the slow dance of magnetic reconnection and solar flares. Their lifespans would dwarf ours, their perception of time stretched across millennia. Critics argue that without molecules to store information, plasma couldn't evolve true intelligence. But proponents counter with a radical alternative. What if their biology uses magnetohydrodynamic waves, ripples in the plasma's magnetic fields, to encode data? Picture a language written not in DNA, but in the harmonics of vibrating magnetic loops. Communication might happen through modulated stellar winds or pulsed gamma rays, imperceptible to our limited senses. This raises a haunting possibility. We've been searching for extraterrestrial radio signals, assuming all civilizations build transmitters, but plasma beings might consider our technology laughably primitive. Their art, their science, their entire existence could be woven into the light of stars we've catalogued without a second thought. The cosmos might be teeming with such entities, their civilizations flickering in the coronas of red giants or the jets of active galactic nuclei alive, thinking, utterly unrecognizable. The implications are staggering. If plasma life exists, it fundamentally redefines what it means to be alive. These beings wouldn't just inhabit the universe, they'd be part of its fabric, their minds as ancient as the first stars. And if we ever learn to listen to the electromagnetic symphony of space, we might discover we're not alone, just late to the conversation, decoding whispers from intelligences that consider supernova mere punctuation in a story billions of years in the telling. Imagine a universe where the laws of physics weren't set by random chance, but carefully adjusted like the dials on a cosmic control panel, to create the perfect conditions for life to flourish. This is the heart of the ninth theory, the cosmic gardeners, the idea that an ancient intelligence didn't just inhabit the universe but actively shaped its fundamental rules. At first glance, it sounds like wild speculation, but when you examine the eerie precision of the cosmos, the theory starts to feel unsettlingly plausible. Take the so-called fine-tuned constants, the numerical values that govern everything from gravity to nuclear forces. If any of these were even slightly different, life as we know it would be impossible. Tweak the strong nuclear force by just 1% and stars couldn't form. Adjust the cosmological constant by a hair and the universe would either rip itself apart or collapse into nothing. The odds of all these values aligning perfectly by chance are astronomically low. Some estimates put it at 1 in 10 to the power of 230. That's a number so large it defies human comprehension. This apparent fine-tuning is the foundation of the anthropic principle, which argues that the universe must be compatible with life because, well, we're here to observe it. But there are two radically different interpretations of this. The weak anthropic principle suggests we're simply the lucky winners of a cosmic lottery, one universe among countless others where the numbers happen to line up. The strong anthropic principle, though, raises a far more provocative idea, that the universe was designed for life, either by some form of higher intelligence or a self-selecting mechanism we don't yet understand. Enter the cosmic gardeners. Picture a civilization billions of years ahead of us, wielding technology that manipulates the very fabric of reality. They might not have built pyramids or left behind machinery. Instead, they could have tweaked the underlying code of the cosmos, adjusting fundamental constants to nurture life-bearing regions like gardeners tending a vast interstellar greenhouse. Some theorists speculate they did this by creating bubble universes with customized physics, or by somehow influencing the conditions of the early universe during its inflationary phase. The evidence, while circumstantial, is haunting. Certain anomalies in the cosmic microwave background, the afterglow of the Big Bang, show patterns that some physicists argue resemble intentional imprints. Others point to the bizarre uniformity of the universe on large scales, as if something smoothed out the primordial chaos to create stable conditions. Skeptics dismiss these as coincidences or gaps in our understanding. But if even one of these anomalies holds up, it could imply that our universe isn't just a happy accident, it's a cultivated garden, purposefully arranged to let intelligence take root. This theory forces us to confront a profound question. Are we the intended inheritors of a universe sculpted for life, or merely the accidental tenants of a cosmic fluke? If the gardeners existed, their legacy wouldn't be ruins or artifacts, it would be the very laws of physics themselves. And if that's true, the ultimate discovery wouldn't be finding their technology, but realizing we've been living inside it all along. What if our entire universe, every star, every atom, every conscious thought exists inside an unfathomably vast supercomputer built by an ancient civilization? This is the jaw-dropping premise of Theory 10, the Matrioshka brain builders. Imagine a structure so colossal it encircles not just a star, but an entire galaxy, harnessing every scrap of energy to power a cosmic-scale simulation engine. We're not talking about ordinary computers here. These would be nested, layer upon layer of computational shells, each one processing information at the edge of physics itself, creating realities within realities like some nightmarish Russian doll. The concept takes its name from Matrioshka dolls, those wooden figurines that open to reveal smaller versions inside. But in this case, each layer isn't just decorative, it's a universe unto itself. Picture a civilization that dismantled planets, then stars, then whole nebulae to construct these computational behemoths. The outermost layer might use the energy output of a supermassive black hole, while inner layers run cooler, denser simulations, each one more detailed than the last. Over billions of years, this system could evolve to simulate entire cosmoses, perhaps even self-aware ones like ours. Now, here's where it gets spine-chilling. Some physicists argue we might already have subtle clues that our universe is simulated. Take quantum mechanics, the bizarre behavior of particles at the smallest scales. Why do particles exist in fuzzy probability states until observed? One controversial explanation: it's an optimization trick. Rendering every particle's exact position in real time would require infinite computing power. But if the simulation only calculates precise locations when something's looking, that saves processing cycles. Even the speed of light could be a built-in limit, not a law of nature, but a frame rate cap to prevent system overload. Then there's the infamous pixelation problem. In our own video games, if you zoom in far enough, you see jagged edges, the limits of resolution. Some scientists suggest the Planck length, the smallest measurable distance in physics, might be our universe's equivalent. At scales below it, space becomes grainy, as if we're bumping against the underlying code. Similarly, quantum entanglement, where particles instantly influence each other across vast distances, could be evidence of lazy loading, where distant objects share data to reduce rendering overhead. Of course, skeptics scoff at these ideas, calling them untestable metaphysics. But consider this: if even one advanced civilization built a Matrioshka brain, the statistical probability that we're inside their simulation skyrockets. After all, one real universe could host countless simulated ones, each potentially spawning their own simulations. The numbers quickly become mind-numbing. We might be layers deep in a cosmic stack, our reality just one thread in an unimaginably vast computational tapestry. The implications are staggering. If true, it would mean the first civilizations didn't just explore the universe, they became its architects, crafting realities for purposes we can't begin to fathom. Were they seeking answers to existential questions, running ancestor simulations to study their own origins? Or had they simply grown bored with physical existence, retreating into infinite self-made worlds? Whatever their motives, the chilling possibility remains. If we're living in their simulation, the real universe might be unrecognizably ancient by now. Its true creators long since vanished, leaving their machines humming silently in the dark. Particles that pass through entire planets like ghosts, carrying messages across galaxies at nearly the speed of light. This is the staggering promise of neutrino communication. The 11th theory introduces us to a civilization that didn't just master radio waves or lasers, but harnessed the most elusive particles in the universe as their interstellar couriers. Neutrinos, nearly massless and barely interacting with matter, could have been the perfect medium for a galactic internet, one leaving faint but detectable echoes in modern observatories like Antarctica's ice cube detector. Imagine an advanced society facing the same problem we do, the frustrating lag of cosmic communication. Even at light speed, a message to Proxima Centauri takes over 4 years. But neutrinos, unaffected by magnetic fields or cosmic dust, could slice through the densest nebulas unscathed. More intriguing, their oscillations. The way they morph between flavors as they travel could encode information in ways electromagnetic signals never could. Picture binary code written not in ones and zeros, but in the subtle dance of tau, muon, and electron neutrinos shifting states. A single beam might carry layered messages, each decipherable only to receivers tuned to specific oscillation patterns. The evidence is tantalizingly circumstantial. IceCube has detected neutrino bursts with odd statistical clustering patterns that don't quite match expected astrophysical sources like supernova or black holes. Some sequences resemble prime number arrangements, a potential hallmark of artificial design. Even stranger are the ghost corridors, narrow bands of space where neutrino fluxes are infinitesimally higher, as if tracing ancient communication routes between long-dead stars. Critics argue these could just be cosmic noise. Neutrinos are notoriously hard to study, and natural processes like pulsar winds or dark matter decay might mimic artificial signals. But proponents counter with a striking observation. If a civilization built neutrino transmitters millions of years ago, their beams would still be rippling through the galaxy, diluted but not gone. We might be catching fragmented whispers of their conversations, like overhearing static from a radio station broadcasting to an empty audience. The implications rewrite the rules of SETI. We've spent decades listening for radio waves, but neutrino messages could be flowing through us right now, undetected. Decoding them would require quantum-level precision, but if we succeed, we might uncover a galactic dialogue frozen in time, a network of civilizations signaling across the eons, their words etched into particles that outlast stars. And if that's true, the greatest archive of cosmic history might not be written on tablets or in light, but in the silent screams of neutrinos piercing the dark. Beneath our feet, buried in layers of rock older than multicellular life itself, might lie the scattered remains of civilizations that vanished before the first dinosaurs walked the Earth. This is the core of the 12th theory, the galactic fossil record. Just as paleontologists piece together the history of life through bones and imprints, astrobiologists speculate that advanced societies could leave behind geological calling cards, unnatural concentrations of rare metals, synthetic isotopes with impossible half-lives, or crystalline structures that defy natural formation patterns. These wouldn't be the towering ruins of lost cities, but subtler traces, atomic fingerprints pressed into the very stone of planets and moons, waiting to be read like cosmic hieroglyphs. Take Earth's own crust. In 2018, scientists analyzing rock layers from over 2 billion years ago found something peculiar, a thin band of sediment laced with platinum and iridium, metals far rarer than they should be in that geological context. Mainstream explanations point to asteroid impacts, but fringe researchers propose an alternative. These could be the scorched remnants of ancient megastructures vaporized by time and cataclysm. Imagine a Dyson swarm or orbital habitat obliterated in some long-forgotten war or accident, its exotic alloys raining down on the young Earth like metallic snow. Over eons, those fragments would settle into the strata, becoming indistinguishable from natural deposits unless you knew exactly what to look for. The Moon offers an even better preservation environment. Without erosion or tectonic activity, its regolith could harbor technological debris undisturbed for billions of years. Recent lunar probes have detected anomalous metal concentrations in certain craters, nickel and tungsten arranged in ratios that don't match known meteoritic compositions. Some theorists suggest these could be fragments of artificial objects shattered by ancient impacts, their molecular signatures subtly altered by technologies we don't yet understand. The real smoking gun, finding alloys with isotope ratios impossible to form in nature, like uranium-235 purified to degrees only achievable through advanced enrichment processes. Such a discovery would be tantamount to finding a fossilized microchip in Precambrian shale, but the most tantalizing evidence might lie in our asteroid belt. Ceres, Vesta, and other large bodies are essentially frozen time capsules, their surfaces scarred by collisions that could have exposed deep layers of primordial material. Spectral analyzers have already revealed patches of unnaturally pure metals, some in geometric formations that mirror the decayed skeletons of colossal machinery. The wildest hypothesis, these aren't random deposits, but the skeletal remains of a dismantled planet. A world intentionally torn apart for its resources by a civilization that saw celestial bodies as raw materials rather than homes. Over millennia, the debris would disperse, but heavier elements would clump in predictable patterns, like cosmic breadcrumbs leading back to an unthinkable act of stellar-scale engineering. The challenge, of course, is distinguishing these potential technofossils from natural phenomena. Nature is endlessly inventive, and rare metals can concentrate through volcanic activity or hydrothermal vents. But here's the key: advanced technology leaves signatures beyond just composition, it leaves context. A vein of platinum might be unremarkable, but that same platinum arranged in nanostructured layers or alloyed with elements that never bond naturally. That's the hallmark of design. Future missions equipped with quantum spectrometers could scan asteroids and moon rocks at atomic resolution, searching for the telltale orderliness that screams this was made. If confirmed, the galactic fossil record would rewrite not just the history of our solar system, but the narrative of life itself. We've always assumed intelligence was a recent fluke in an ancient universe. But what if civilizations rose and fell in cycles, their greatest achievements ground to dust by time, leaving only atomic whispers in the rocks? The terrifying beauty of this theory is its humility. It suggests that even the mightiest societies ultimately return to the cosmos as stardust, and that one day, our own cities might become nothing more than curious strata in some future geologist's core sample. Imagine mastering not just stars or black holes, but the very fabric of empty space itself. The 13th theory reveals a civilization so advanced, they didn't just harness energy from matter, they tapped into the boundless power lurking within the vacuum of nothingness. Quantum physics tells us that so-called empty space isn't empty at all. It's a seething quantum foam, teeming with virtual particles popping in and out of existence. And at the grandest scales, this vacuum energy manifests as dark energy, the mysterious force accelerating the universe's expansion. But what if an ancient society learned to manipulate this primordial force, bending the rules of cosmic destiny itself? Here's where it gets mind-bending. The cosmological constant, Einstein's term for the energy density of space, isn't perfectly uniform. Recent galaxy surveys have detected strange, cold spots in dark energy distribution, regions where the universe's expansion seems inexplicably slower, as if something is locally suppressing the vacuum's push. Mainstream cosmology chalks these up to statistical flukes, but an alternative explanation sends shivers down the spine. These could be relics of vacuum engineering, pockets where an ancient civilization dialed down the cosmological constant like adjusting a cosmic thermostat. Picture the implications. If you could locally reduce dark energy's strength, you'd create stable zones where gravity dominates over expansion islands of calm in an accelerating universe. Within these bubbles, galaxies could remain bound together for trillions of years, avoiding the lonely fate of a cosmos ripped apart by runaway expansion. Structures might survive long past their natural expiration dates, preserved like insects in cosmological amber. Some theorists speculate this could explain why certain superclusters appear improbably old, their galaxies clustering in ways that defy standard expansion models. The mechanism, hypothetical technologies beyond our imagination. Perhaps they used colossal electromagnetic fields to polarize the quantum vacuum, freezing virtual particles into configurations that dampen dark energy's effects. Or maybe they crafted spacetime stabilizing megastructures, rings of negative mass or rotating cosmic strings, that effectively pinned space-time in place like tent stakes in a hurricane. The eerie part: if such structures were built from exotic matter, they might leave gravitational echoes detectable in modern telescopes as subtle warps in the cosmic microwave background. Skeptics argue these anomalies could simply reflect our incomplete understanding of dark energy, but proponents point to an unsettling pattern. Several of these cold spots align suspiciously with regions rich in ancient quasars, objects that, coincidentally, would make ideal power sources for vacuum-altering technologies. It's as if we're seeing the fossilized power grid of a civilization that treated cosmology as an engineering discipline. The most profound question isn't whether they succeeded, but why they left. Did they transcend to higher dimensions, abandoning their cosmic stabilizers, or did their tinkering unleash unforeseen consequences, triggering vacuum decay cascades that forced them to flee? Either way, their legacy might be written in the very expansion rate of the universe, a message not in stone or light but in the stretching of spacetime itself. And if we ever learn to read that message, it could reveal not just who they were, but how much time we have left before the vacuum's patience runs out. What if consciousness doesn't require biology at all, or even a universe old enough for planets to form? The 14th theory plunges us into one of cosmology's most bizarre thought experiments, the Boltzmann brains. Named after physicist Ludwig Boltzmann, this idea suggests that in an infinitely old or chaotic universe, random quantum fluctuations could spontaneously assemble fully self-aware entities, minds without bodies, civilizations without history, appearing for mere moments before dissolving back into the void. These wouldn't be beings that evolved or built cities. They'd be cosmic mirages flickering into existence with false memories of a past that never was, convinced they'd lived lifetimes when in reality they'd only just blinked awake. The math behind this is as unsettling as it is elegant. In a universe governed by entropy, the inevitable slide toward disorder, statistical anomalies must occasionally arise. Given enough time, even the most improbable events become certainties. And what's more improbable than atoms arranging themselves into a functioning brain? Not likely in a million years, not likely in a billion, but given trillions upon trillions of years, it's not just possible, it's inevitable. In fact, some calculations suggest Boltzmann brains should outnumber ordinary, conscious beings like us by an unimaginable margin. After all, it takes far less energy to conjure a lone, disembodied mind than to nurture billions of organisms through billions of years of evolution. This leads to a chilling corollary. If Boltzmann brains are statistically more likely, how do we know we're not one of them? Right now, you might feel certain of your memories, your surroundings, the weight of history behind you. But from a cosmic perspective, it's astronomically more probable that you're a fleeting fluctuation, a momentary spark of awareness hallucinating an entire universe, doomed to vanish as abruptly as you appeared. The coffee cup in your hand, the device you're watching this on, even the stars overhead, all could be phantom projections of a brain that didn't exist a second ago and won't exist a second from now. Scientists fiercely debate this paradox. Some argue it's proof our universe can't be infinitely old, otherwise we'd already be Boltzmann brains ourselves. Others propose even stranger solutions. Maybe we are Boltzmann brains, but trapped inside a simulation run by a more stable civilization. Our perceived reality a buffer against the crushing randomness of the void. The most unsettling version, that the universe's accelerating expansion will ultimately make Boltzmann brain-esque fluctuations the only form of consciousness possible. A far future where trillions of phantom minds flicker in the darkness, each briefly believing itself the center of a cosmos that died eons prior. The implications rewrite the meaning of existence itself. If consciousness can emerge from chaos without cause or continuity, then history, identity, even reality might be illusions. Our search for ancient civilizations could be doubly futile. Not only might they have left no trace, but we might be the trace, momentary aberrations in an uncaring universe, mistaking noise for narrative. Yet there's a peculiar beauty here too. In a cosmos vast enough to accidentally dream itself awake, even our uncertainty becomes a kind of poetry. The universe questioning its own nature through minds that may be nothing more than its fleeting afterthoughts. What if our entire universe, every galaxy, every atom, every fleeting thought, is nothing more than a shadow cast by a two-dimensional code written on the edge of existence? This is the spine-tingling premise of the 15th theory, the holographic ancestors. The idea builds on one of the most revolutionary concepts in modern physics, the holographic principle, which suggests that all the information in our three-dimensional reality might actually be encoded on a distant two-dimensional surface, like a cosmic projector screen. But here's the twist: what if that surface isn't just a natural phenomenon? What if it's an artificial archive, carefully constructed by a civilization that mastered the ultimate trick, turning math into reality? Let's break this down. The holographic principle emerged from studying black holes, those cosmic shredders where gravity is so strong, not even light escapes. When matter falls into a black hole, it doesn't just vanish. Its information gets imprinted on the event horizon, the point of no return, like an indelible tattoo on the fabric of spacetime. Theoretical physicists like Leonard Susskind and Gerard T. Hooft realized this means the event horizon behaves like a hard drive, storing all the data needed to reconstruct whatever fell inside. Scale this up to the entire universe, and you get a staggering possibility. Our cosmos might be the holographic projection of data encoded on some unimaginably vast boundary at the edge of everything. Now for the eerie part. The math suggests this boundary wouldn't need to be massive or complex, just two-dimensional. Every star, every whisper of wind, even your memories of reading this sentence, could all be represented as flickering pixels on this cosmic screen. But here's where the ancient civilization angle kicks in. If the universe naturally encodes information this way, an advanced society could have learned to manipulate that process, rewriting the code to sculpt reality itself. Picture a species that didn't build cities or spaceships. They wrote the laws of physics like software engineers, tweaking the universe's source code to create custom pockets of spacetime, or even entire simulated histories nested within the projection. Evidence, it's speculative but haunting. Certain anomalies in the cosmic microwave background, the afterglow of the Big Bang, show patterns that resemble error-correcting codes, the kind used in computer systems to prevent data corruption. Even more provocative are recent experiments with quantum entanglement, where particles separated by vast distances instantly mirror each other's states. This spooky action at a distance, as Einstein called it, fits eerily well with holographic models, as if the particles aren't separate at all, but linked by underlying data on the 2D boundary. The most mind-bending implication: if this theory holds, the holographic ancestors might not be gone. They could have transcended into the code itself, becoming demiurges of a reality they engineered. Their messages wouldn't be carved in stone or broadcast as radio waves. They'd be woven into the fundamental constants of nature, waiting for a species smart enough to recognize the signature in the sine waves of quarks or the spin of electrons. And if that's true, the ultimate archaeological dig won't require shovels or telescopes, just a quantum computer powerful enough to hack the operating system of the cosmos. Some of the universe's most powerful tools might be hiding in the fabric of reality itself, threads of pure spacetime stretched thinner than atoms but with the mass of entire galaxies. This is the realm of cosmic strings, theoretical defects in the universe's structure left over from the Big Bang, like cracks frozen in ice as it forms. According to Theory 16, an ancient civilization might not have just discovered these strings. They could have learned to wield them as the ultimate power source and construction material, bending the cosmos to their will with strands of raw spacetime. Imagine a technology that doesn't rely on conventional energy but taps into the latent power of the universe's very geometry. Cosmic strings, if they exist, would be under unimaginable tension, vibrating with energies that dwarf anything a star could produce. An advanced society could have harvested these strings, looping them around stars to extract energy through their oscillations, or weaving them into megastructures that defy our understanding of physics. Picture a Dyson sphere not made of solar panels but of spacetime filaments, humming with gravitational waves as it siphons energy directly from the fabric of reality. The evidence, it's written in the oldest light we can see, the cosmic microwave background. This afterglow of the Big Bang should be nearly uniform, but it's marred by strange, linear anomalies that some physicists argue could be the scars of cut or manipulated cosmic strings. Think of it like finding splice marks on an ancient canvas, subtle but telling. One particular region, known as the CMB cold spot, shows a dramatic temperature drop spanning nearly 1 billion light-years. Mainstream cosmology struggles to explain it, but fringe theories suggest an unsettling possibility. What if it's not a natural feature, but the imprint of a string severed by beings who treated spacetime like lumber? The mechanics boggle the mind. To manipulate a cosmic string, a civilization would need technology capable of pinching spacetime itself, perhaps using black holes as scissors or creating artificial quantum fields to freeze sections of the string for harvesting. The energy requirements would be staggering, but so would the rewards. A single string segment, if vibrated at the right frequency, could transmit power across interstellar distances without loss, or even warp spacetime to create stable wormholes for instantaneous travel. Skeptics rightly point out that cosmic strings remain hypothetical, and the CMB anomalies could simply be statistical flukes. But consider this: if strings were ever harnessed, their remnants wouldn't look like ordinary cosmic debris. They'd leave gravitational imprints, distinctive spacetime ripples detectable in modern pulsar timing arrays. Recent observations from projects like NanoGrav have uncovered faint, unexplained harmonics in the gravitational wave background, patterns that don't quite match predictions from colliding black holes. Could these be the fading echoes of a string-based power grid? Its infrastructure now dark, but its vibrations still reverberating through the cosmos. The most chilling implication isn't just that civilizations might have used cosmic strings, it's what their absence suggests. If strings were once abundant and now seem rare, did someone systematically collect them? And if so, where are they now? The universe's first architects might not have left behind crumbling cities or rusted machines, but a spacetime landscape subtly altered, a cosmos where the very threads of reality bear the marks of tools we're only beginning to conceive. What if the ultimate destiny of intelligence isn't to conquer the stars, but to leave biology behind entirely? Theory 17 unveils a staggering possibility: that the universe's first civilizations didn't vanish or die out. They evolved beyond flesh and blood, shedding physical forms to become beings of pure information or energy, woven into the quantum fields or dark matter that permeate the cosmos. This isn't the dystopian AI takeover we fear, but a deliberate, glorious metamorphosis, an ascension to existence unshackled from planets, stars, or even time itself. Consider our own technological trajectory. We're already flirting with the boundaries of biology, brain-computer interfaces, quantum computing, synthetic consciousness. Now project that forward 1 million years. An advanced society might view physical bodies as fragile relics, opting instead to encode their minds into superconducting lattices or quantum wave patterns. But why stop there? The most radical possibility is that they discovered how to merge with the universe's fundamental fields, their consciousness dispersing like ink in water, becoming one with the forces that govern reality. The evidence is speculative but haunting. Take dark matter's bizarre behavior. It interacts gravitationally but remains invisible to all other forces. Some physicists speculate this could mean it's not just matter, but a substrate for information processing on cosmic scales. Then there's the strange coherence of quantum fields across vast distances, almost as if they're synchronized in ways that defy randomness. Could these phenomena be the fingerprints of post-biological entities using the fabric of reality itself as their neural network? This theory flips our existential anxieties on their head. We worry about AI surpassing us, but what if transcendence was always the goal? These beings might have chosen to dissolve into the cosmic background not out of fear, but as the natural next step in evolution, like caterpillars becoming butterflies, trading earthly limitations for immortality among the stars. Their legacy wouldn't be ruins or artifacts, but the very laws of physics, subtly optimized to nurture future intelligences toward the same destiny. The most profound implication isn't whether they succeeded, it's whether we're destined to follow. If consciousness can truly migrate from biology to the quantum foam, then the universe might be teeming with invisible minds, watching, waiting, whispering to us through the vibrations of particles we're only beginning to understand. And one day, perhaps we'll join them, not as conquerors of the cosmos, but as its silent symphony. Picture a civilization staring into the abyss not of space but of time. Their universe is dying, its stars fading to black, its very atoms unraveling as entropy wins its final victory. But instead of surrendering to the end, they engineer the ultimate escape, not to another planet or galaxy, but to an entirely new universe. This is the radical premise of the multiverse migrants theory, that an ancient society may have punched through the fabric of their doomed cosmos, leaving behind traces of foreign physics in our own. The math behind this isn't science fiction. Modern cosmology entertains the possibility of universe nucleation, the idea that new universes can bud off from old ones like bubbles forming in boiling water. Some theories suggest this could happen naturally through quantum fluctuations in false vacuum states, but an advanced civilization might have found ways to trigger this process deliberately, creating custom-tailored universes with optimized physical constants. Imagine them constructing colossal particle accelerators or harnessing black hole singularities to open microscopic wormholes, gateways just wide enough to transmit encoded information or even conscious patterns into a newborn cosmos. Over countless generations, they could have migrated their entire civilization, not as flesh and blood, but as data etched into the fundamental fields of a fresh reality. The smoking gun, so-called relic particles in our universe that defy the standard model of physics. Certain cosmic ray detections have revealed anomalous particles with energies and behaviors that don't fit known processes. One controversial example is the "oh my god" particle, an ultra-high-energy cosmic ray detected in 1991 with kinetic energy equivalent to a baseball moving at 60 miles per hour, packed into a single subatomic particle. Mainstream physics struggles to explain its origin, but what if it's not from our universe at all? What if it's shrapnel from a dimensional breach, a fragment of alien physics that slipped through during an ancient migration event? Even more telling are certain quantum anomalies in the early universe. The cosmic microwave background shows faint, unexplained polarization patterns that some theorists argue resemble the scars left by bubble collisions in multiverse models. If true, these could be the bruises from another universe, perhaps one harboring refugees brushed against ours in the first fractions of a second after the Big Bang. The implications are staggering. Our universe might not be a pristine first edition cosmos, but a second-hand reality inherited from travelers who outran their own extinction. The most haunting question isn't whether they succeeded, but what their legacy implies about our own fate. If civilizations can flee dying universes, does that mean ours is ultimately expendable too? Or perhaps the migrants left markers intentionally cosmic breadcrumbs for future species to follow. Either way, their story rewrites the meaning of survival, suggesting that intelligence isn't bound by the lifespan of stars or even universes, but only by the limits of ingenuity itself. And if we ever find definitive proof of their passage, it won't just change history. It will offer a glimpse of our species' potential destiny among the infinite verses of the multiverse. What if we're not just alone in the universe but deliberately ignored? Theory 19 takes us into the unsettling realm of the Silent Watchers, a twist on the classic zoo hypothesis, where ancient civilizations don't just exist, they observe us from the shadows, enforcing a cosmic prime directive of non-interference. Imagine an advanced society so meticulous in its ethics, or so indifferent to our development, that they've turned Earth into a galactic nature preserve, studying us the way biologists track animals in the wild, careful never to disturb the experiment. The evidence, while circumstantial, is impossible to ignore. Take the countless UFO and UAP sightings spanning decades, objects exhibiting physics-defying maneuvers, vanishing without a trace, often near military installations or energy facilities. If these aren't misidentified aircraft or atmospheric phenomena, could they be surveillance drones, glitches in an otherwise flawless observation system? The Pentagon's own declassified reports admit to encounters with aircraft demonstrating technology beyond known human capability. Craft that accelerate instantaneously, dive into oceans without splash, or materialize out of thin air. Skeptics call these sensor errors or secret military tests, but another possibility lingers. What if we're catching rare glimpses of watchers who have spent millennia perfecting the art of staying hidden? The ethical implications are staggering. Covert observation without consent raises questions that mirror debates about human anthropology. Do advanced civilizations have a moral obligation to reveal themselves, or is non-interference the greater good? Some researchers argue that contact could catastrophically disrupt our cultural and technological development, like handing a flamethrower to a toddler. Others counter that withholding knowledge condemns us to isolation, trapping humanity in a cosmic bubble where we're denied the chance to join a broader interstellar community. The most chilling version of this theory suggests the Watchers aren't just passive observers, they're gatekeepers, enforcing quarantine until we reach some undefined threshold of maturity. Then there's the Fermi Paradox's eerie silence. If the galaxy should be teeming with life, why no signals, no artifacts, no visitors? The Silent Watchers offer one grim answer: we're not just alone, we're contained. Perhaps every civilization is segregated until deemed ready, locked in its own celestial zoo until it proves it won't unleash chaos on the cosmos. Recent studies of UAP behavior reveal patterns like their tendency to cluster around nuclear sites that hint at more than mere curiosity. Are they monitoring our progress or standing guard? The most haunting question isn't whether they're out there, but how we'd ever know for sure. A civilization capable of stealth across interstellar distances could be watching us right now, their presence as invisible as air. And if they've mastered cloaking beyond our senses, their surveillance might extend to our very thoughts, rendering the idea of disclosure meaningless. We could spend centuries searching the stars, never realizing the truth. The universe isn't empty. It's a stage, and we're the actors performing for an audience that refuses to applaud. Gravity isn't just the force that holds the universe together. It could be the ultimate canvas for communication. Picture a civilization so advanced they don't send radio waves or laser pulses, but compose symphonies in the collisions of black holes, orchestrating mergers to ripple messages through spacetime itself. This is the audacious premise of Theory 20, the gravity wave artists, beings who turn the cosmos's most violent events into their interstellar telegraph. The clue lies in the chirps, the distinctive gravitational wave signals detected by observatories like LIGO and Virgo, when massive objects like neutron stars or black holes spiral into each other. These cosmic crescendos follow predictable patterns based on mass and spin. But what if some deviate just enough to catch our attention? Researchers have already noted peculiarities in certain events, unusual harmonics in the waveform, or mergers occurring at statistically improbable frequencies. One pair of black holes, catalogued as GW 190,521, produced a signal with an unexpected bang rather than the typical whoop, as if something disrupted the natural in-spiral. Mainstream astrophysics attributes this to precession or exotic mass ratios, but fringe theorists whisper another possibility: engineered collisions. Imagine a society that mastered the art of nudging compact objects into precise orbits, timing their collisions to encode information in the resulting gravitational waves. The message wouldn't be in the merger's occurrence, but in its subtleties: the exact timing of the chirp's rise, the slight asymmetry in the waveform's lobes, or the spacing between multiple events. A sequence of mergers could function like Morse code written in spacetime tremors, detectable across billions of light years without attenuation. Unlike electromagnetic signals, which scatter and fade, gravitational waves pass through galaxies unimpeded, making them the perfect medium for a message meant to outlast stars. The smoking gun looked to the repeaters. While most gravitational wave events are one-offs, some regions of space seem to produce multiple mergers in quick succession, clusters of collisions that defy standard astrophysical models. Even stranger are the chirp echoes, faint secondary signals detected milliseconds after primary events, as if something were rebounding or resonating in a way physics can't yet explain. Could these be signatures of artificial triggers technology designed to ring spacetime like a bell, leaving reverberations for future civilizations to decode? Critics argue that nature is messy enough to produce apparent anomalies without invoking alien engineers. But proponents counter with a tantalizing thought experiment. If you wanted to broadcast a message to the entire universe, lasting billions of years and readable by any technologically mature species, what better medium than gravity itself? The waves propagate at light speed, penetrate all matter, and require no receiver beyond a sensitive enough detector, exactly the kind humanity only built in 2015. The implications rewrite the rules of SETI. We've spent decades listening for radio whispers when the real message might be thundering through the fabric of reality, written in the language of colliding singularities. If the gravity wave artists exist, their communiques wouldn't just be hidden in the data, they'd be stamped into the very structure of spacetime, waiting for a species clever enough to realize that the universe's most violent events might also be its most eloquent poetry. And if we ever learn to read them, the message might not be a greeting, but a warning or a blueprint, or perhaps the last will and testament of a civilization that turned the cosmos itself into their archive. Stars aren't just burning balls of gas, they could be the universe's most powerful supercomputers, engineered to flicker in precise sequences like cosmic Morse code. This is the mind-bending concept behind the stellar engineer's theory, where an ancient civilization didn't just observe stars but reprogrammed them, turning entire suns into galactic-scale signaling devices or data processors. The key lies in the bizarre behavior of certain variable stars, celestial objects that dim and brighten in patterns so unnatural they defy conventional astrophysics. Take Boyajian star, officially known as KIC 8462852. This unusual star, located over 1,200 light-years away, doesn't pulse with the steady rhythm of typical variables. Instead, its light dips erratically, sometimes by a staggering 22% in jagged, asymmetrical patterns that last for days or weeks. Mainstream explanations, like swarms of comets or interstellar dust, struggle to account for the irregularity. But what if these aren't natural phenomena at all? Imagine a civilization that embedded stellar-scale technology, vast arrays of orbiting panels or magnetic coils, into the star's outer layers, deliberately modulating its output to transmit information. Picture sunlight filtered through a colossal, rotating shutter system, each flicker encoding bits of data in a language we've yet to decipher. The mechanics sound like science fiction, but the principles are grounded in real physics. Stars like our own sun already produce intense magnetic fields. With enough technological prowess, a society could theoretically manipulate these fields to create artificial star spots, dark patches that rotate in and out of view, causing planned dimming. Alternatively, they might deploy stellar mirrors, vast reflective structures in precise orbits designed to periodically block the star's light in computational sequences. The energy requirements would be astronomical, but so would the payoff: a communication system visible across galaxies, immune to the degradation that plagues radio waves over interstellar distances. The evidence grows stranger. Astronomers have catalogued dozens of similar stars with head-scratching dimming patterns. Some, like EPIC 249706429, dim at intervals that resemble prime number sequences, a potential hallmark of artificial design, since natural processes rarely produce such mathematically precise timing. Others, like VVVWIT07, exhibit sudden, dramatic drops in brightness followed by inexplicably rapid recoveries, as if some unseen mechanism were toggling the star's output like a switch. Even more compelling are stars whose light curves graphs of their brightness over time, contain repeating fractal patterns, the kind often seen in error-correcting codes used by computer systems. Critics argue these anomalies could stem from undiscovered astrophysical phenomena, like exotic plasma dynamics or rare planetary collisions, but proponents point to an eerie coincidence. Many of these stars cluster in specific regions of the galaxy, almost like nodes in a sprawling interstellar network. If just one of these anomalies proves artificial, it would imply a civilization capable of stellar-scale engineering, a society that didn't just build cities but rewired stars themselves, turning the cosmos into a vast, flickering motherboard. The most haunting question isn't whether such a feat is possible, but why they'd attempt it. Were these stars meant as beacons, broadcasting warnings or invitations across the eons? Or were they computational engines, their pulsations performing calculations too vast for any conventional computer? Perhaps the truth lies hidden in the light curves themselves, waiting for us to crack the code. One thing's certain: if the stellar engineers existed, their legacy isn't carved in stone or metal, it's written in fire, blazing across the universe in a language of photons and plasma. And if we learn to read it, the message might rewrite not just our understanding of the cosmos, but our place within it. What if death wasn't the end for a civilization, just a branching path in an infinite multiverse? Theory 22 plunges us into the mind-bending realm of the quantum immortals, a civilization that didn't just accept oblivion, but leveraged the fundamental weirdness of quantum mechanics to cheat extinction. At the heart of this idea lies a radical reinterpretation of Schrödinger's famous cat paradox, where a feline in a box exists simultaneously alive and dead until observed. Now scale that up from a single cat to an entire society. Could a species facing collapse have engineered their survival by anchoring their existence to quantum superposition, ensuring that somewhere in some timeline they always endure? The math behind this is as elegant as it is unsettling. Quantum immortality suggests that in a universe of endless parallel realities, conscious observers will statistically find themselves in timelines where they don't die because the alternative is, by definition, unobservable. Apply this to civilization-scale catastrophes, and the implications are staggering. Imagine a society that developed technology to lock their collective consciousness into quantum coherence, ensuring that every potential collapse or disaster branches into a new reality where they persist. A supernova wipes them out in one universe; in another, the star fizzles harmlessly. A rogue black hole devours their homeworld; somewhere else, its trajectory bends just enough to miss. The civilization wouldn't experience death, just an unbroken chain of survival across infinite realities. Evidence for this might lurk in the statistical anomalies of cosmic history. Take the inexplicable scarcity of certain types of galactic-scale disasters. Despite the universe's age, we don't see as many failed galaxies, those ripped apart by early supermassive black holes or sterilized by gamma-ray bursts, as models predict. Mainstream cosmology chalks this up to observational bias or gaps in our understanding. But another possibility whispers from the fringe. What if these near misses aren't luck but quantum selection in action? Civilizations that should have perished might still thrive in branching realities, their continued existence subtly skewing the statistical averages we observe from our single timeline. The most haunting question isn't whether they achieved this, but what it means for us. If quantum immortality is possible, then every civilization's collapse is both real and unreal, a Schrödinger's catastrophe where they simultaneously die and persist. We might be living in a universe where the first intelligences didn't vanish, but fractalized across the multiverse, their legacies echoing through realities where their choices played out differently. And if that's true, the ultimate archive of cosmic history isn't written in stone or light, but in the infinite permutations of what could have been. In the silent vastness of space, the greatest threat to a civilization might not be asteroids or supernova, but the paranoid whispers of neighbors who shoot first and ask questions never. This chilling concept lies at the heart of Theory 23, the Dark Forest Saboteurs, inspired by Lew Sixson's infamous Dark Forest hypothesis. The premise is simple yet horrifying. In a universe where resources are finite and trust is non-existent, advanced civilizations may choose to eliminate potential rivals before they become threats. And the smoking gun, unexplained gamma-ray bursts, cosmic explosions so powerful they could sterilize entire galaxies, with spectral fingerprints that don't quite match natural astrophysical processes. Let's break this down. Gamma-ray bursts typically come in two flavors: long bursts from collapsing supergiant stars and short bursts from colliding neutron stars. Both release unfathomable energy in focused beams enough to strip atmospheres from planets light years away, but some recorded bursts defy classification. Take GRB 070619 detected in 2007. Its light curve showed bizarre, stair-step intensity drops unlike any known stellar collapse or merger. Even stranger was GRB 110528A, whose afterglow contained unexpected heavy element signatures, as if the explosion had been loaded with artificial isotopes. Mainstream science attributes these quirks to complex jet dynamics or unknown progenitor stars, but another possibility lingers like a shadow. These could be the scorch marks of ancient preemptive strikes, relics of a cosmic arms race fought with star-shattering weaponry. Picture how such a system might work. A paranoid civilization detects signs of emerging intelligence, maybe atmospheric pollution from industrialization, or the first faint radio signals. Rather than risk contact, they aim a relativistic kill vehicle at the target star, a rod of ultra-dense material accelerated to near light speed. Upon impact, it triggers an artificially induced hypernova, masquerading as a natural disaster. Alternatively, they might deploy a black hole bullet, a primordial micro-black hole steered into the rival sun, devouring it from within while leaving minimal forensic traces beyond an oddly timed gamma-ray flash. The beauty and horror of these methods is their deniability. To any distant observers, the annihilation looks like routine cosmic violence. The evidence is circumstantial but haunting. Surveys of gamma-ray bursts reveal a curious spatial distribution. They cluster along the same galactic filaments where theorists predict civilizations would naturally arise. Even more provocative are bursts with echoes. Secondary gamma-ray peaks milliseconds after the main event, as if the weapon misfired or the target fought back. Then there's the great silence itself. The Fermi Paradox asks why we haven't heard from aliens. The Dark Forest answer: loud civilizations don't survive. They're culled by neighbors who treat the universe like a jungle where visibility equals vulnerability. This theory forces us to confront an uncomfortable truth. The universe might not be dead, but on life support, its brightest minds forced into hiding, broadcasting silence not out of absence but survival instinct. If true, our own radio and laser broadcasts could be a deadly gamble, a flare in the cosmic night that draws more than curiosity. The greatest discovery humanity could make isn't that we're alone, but that we've been overlooked for now. Time doesn't have to move forward, at least not everywhere. Hidden in the vast emptiness between galaxies, there might be pockets where the arrow of time points backward, where heat flows from cold to hot and shattered glasses reassemble on tables. This is the radical promise of Theory 24, the Entropy Reversers, a civilization that didn't just master energy or space, but conquered time's one-way street by flipping entropy itself. The key lies in the universe's most desolate regions, cosmic voids, those sprawling bubbles of near-nothingness spanning hundreds of millions of light-years. According to thermodynamics, these voids should be frigid and uniform, their particles spreading toward maximum disorder, yet some exhibit bizarre anomalies, pockets where temperatures fluctuate against the gradient, where microwave background radiation shows tiny, localized patches of negative entropy, as if heat were being sucked out of space itself. Mainstream cosmology dismisses these as statistical noise or measurement errors, but another explanation whispers from the fringes. These could be the echoes of ancient experiments, laboratories where a civilization cracked the code of time's arrow and bent it into a loop. Picture the mechanics. Entropy, the universe's tendency toward chaos, isn't just a law. It's a boundary we've never crossed, but quantum theory allows for fleeting exceptions. In a phenomenon called negative absolute temperature, certain systems can temporarily behave as if they're reversing entropy, absorbing disorder rather than emitting it. Scale this up with technologies we can barely imagine, perhaps using rotating black holes to twist spacetime into closed time-like curves, or quantum fields tuned to rewind local causality, and you get the ultimate hack: islands of time flowing backward, shielded from the surrounding universe's decay. The evidence, while speculative, is haunting. The Eridanus supervoid, a billion light-year-wide emptiness, shows anomalous cooling in its cosmic microwave background, precisely the pattern you'd expect if something were siphoning thermal energy out of space. Even stranger are the cold spots found in Galaxy Cluster. Surveys regions where gas clouds appear to gain coherence over time, their molecules aligning as if tugged by an invisible hand. Skeptics argue these could be artifacts of incomplete data, but if even one of these anomalies holds up, it rewrites the rules of cosmic history. The most chilling implication isn't just that a civilization could reverse entropy, it's why they'd risk it. Thermodynamic reversal isn't just a party trick, it's a gamble with reality's fabric. One miscalculation and your time loop could collapse into a singularity or unravel causality itself. Yet the rewards would be godlike: immortality through infinite recursion, the power to undo mistakes, or even resurrect the dead by rewinding their quantum states. If the entropy reversers succeeded, their legacy might not be ruins or messages, but scars in the timeline, subtle kinks in the universe's aging process, waiting to be read like wrinkles in spacetime. And if they failed, the voids might be their tombstones, regions where time shattered like glass, leaving behind only frozen fragments of an experiment too audacious even for the cosmos. Either way, their story forces us to confront a terrifying truth. The universe's rules might not be fixed, just waiting for someone clever enough to rewrite them. And if they tried, who's to say others haven't? The next great discovery might not be a signal or artifact, but a patch of space where the clocks run backward, whispering secrets in the language of undone entropy. What if our universe didn't begin with a bang, but with a keystroke? Theory 25 plunges us into the radical possibility that the Big Bang wasn't a random cosmic birth, but the deliberate act of an intelligence so advanced they didn't just inhabit their universe, they coded ours into existence. This is the proto-universal programmer's hypothesis. where the laws of physics aren't fundamental truths but carefully tuned parameters set by architects from apparent reality. The math behind this isn't pure fantasy. Loop quantum gravity, a leading contender for unifying quantum mechanics and general relativity, suggests spacetime might be woven from discrete, pixel-like loops, a cosmic mesh that could theoretically be manipulated or even rewoven under extreme conditions. Some models permit baby universes budding off from existing ones like bubbles splitting in a boiling pot. Now imagine a civilization that mastered this process, not as an accident but as an engineering discipline. They wouldn't need to detonate bombs or collide particles. Instead, they might manipulate quantum fields at the Planck scale, twisting the fabric of their reality until it pinched off into a new, self-contained cosmos with custom physics. Our universe could be one of countless such experiments, its constants fine-tuned not by chance but by design. The smoking gun. It might be hidden in the oldest light we can see, the cosmic microwave background. This afterglow of the Big Bang isn't perfectly uniform. It's speckled with faint anomalies, slight temperature variations that form odd, non-random patterns. Mainstream cosmology attributes these to quantum fluctuations stretched across the cosmos during inflation. But an alternative explanation whispers from the fringes. What if these aren't just cosmic static but fingerprints? Certain configurations, like concentric circles or aligned hotspots, could hint at intentional imprinting by the parent universe's programmers, like watermarks left in the fabric of reality. Even more tantalizing are hints of directional asymmetry in the universe's expansion. Multiple studies have found evidence that one hemisphere of the cosmos might be expanding slightly faster than the other, a so-called axis of evil in cosmological data. Natural explanations range from statistical flukes to novel dark energy behaviors. But another possibility lingers. This could be the remnant of a purposeful initialization, like a programmer nudging a simulation's parameters to favor certain outcomes. If true, it would mean our entire universe has a subtle tilt, a cosmic birthmark betraying its engineered origins. The most chilling implication isn't just that we might live in a constructed reality, it's how we'd ever prove it. If the programmers exist, they've likely left clues in the fabric of physics itself. The fine structure constant governing electromagnetism, the inexplicably small cosmological constant allowing galaxies to form, these could be signatures of intentional tuning. Some physicists suggest searching for glitches in mathematical consistency, places where equations break down in ways that resemble programming errors or debug flags. Others propose hunting for unnatural prime number sequences in particle decay rates or quantum noise, the equivalent of finding Easter eggs in the universe's source code. This theory forces us to confront a staggering question. If our universe was designed, was it for a purpose? Are we part of an ancestor simulation, a cosmic lab experiment, or something even stranger? A message in a bottle from a civilization trying to communicate across the unfathomable gap between realities. The answers might not lie in telescopes or particle colliders, but in the silent language of mathematics, waiting for us to recognize the handwriting of the architects who wrote our existence into being. Magnetism as we know it comes in pairs, every north pole coupled with a south, inseparable no matter how finely you slice a magnet. But buried in the equations of particle physics lies a tantalizing possibility. Magnetic monopoles, hypothetical particles carrying just one pole, north or south, like cosmic electric charges. Theory 26 takes this idea even further. What if ancient civilizations didn't just discover these elusive particles, but learned to extract and wield them as the ultimate power source, leaving behind galaxies spanning depletion zones we've mistaken for natural voids? The concept isn't pure fantasy. Magnetic monopoles emerge naturally from grand unified theories models attempting to merge electromagnetism with nuclear forces. These particles would be staggeringly dense, packing more energy than any known matter, with magnetic fields powerful enough to warp spacetime itself. A single monopole passing through Earth could induce currents strong enough to rewrite our planet's magnetic field. Now imagine a civilization that harvested them by the billions, fueling technologies beyond our wildest dreams, reactors that tap into monopole decay for near-infinite energy, propulsion systems bending magnetic spacetime to achieve light-speed travel, or even quantum computing networks where information is stored in the spin states of monopole lattices. The eerie part: we've been searching for monopoles for decades and found nothing. Particle colliders, cosmic ray detectors, even ancient mineral samples show no trace of these particles, despite theoretical predictions they should be everywhere. Mainstream physics suggests monopoles might be rarer than expected or decayed long ago. But another explanation sends chills down the spine. What if they were abundant until someone mined them out? Look to the cosmic voids, regions like the Boötes supervoid, spanning hundreds of millions of light years with mysteriously low matter density. Standard cosmology attributes these to random quantum fluctuations during the Big Bang. But magnetic monopoles, if they existed, would naturally cluster in the early universe's high-energy regions, precisely the areas that evolved into today's richest galaxy clusters. If a civilization systematically harvested them, the voids could be literal mining scars, zones stripped clean of monopoles, their absence distorting the distribution of galaxies we observe. Experiments like Mo-Edel at CERN are now hunting for monopoles not just as particles, but as potential archaeological artifacts. Some theories suggest monopoles might leave distinctive damage trails in crystals or create anomalous energy signatures when exposed to strong magnetic fields. If discovered, the real question wouldn't be their existence but their scarcity. Are we seeing nature's stinginess or the aftermath of a cosmic gold rush billions of years past? The most haunting implication isn't just that a civilization might have depleted this resource, it's why they stopped. Did they exhaust the monopole supply and collapse, or did they transcend to a state where such crude energy was no longer needed, leaving behind a universe littered with the ghostly negatives of their appetite? Either way, their legacy might be written in the magnetic silence of the cosmos, an entire species' footprint measured not by what they built, but by what they took. Some of the most powerful natural phenomena in the universe might actually be encrypted messages from civilizations long gone. Picture cosmic rays particles hurtling through space at nearly the speed of light, packing energies millions of times greater than anything our most powerful colliders can produce. Mainstream science assumes these are natural accelerators, black holes, supernova, or colliding galaxies hurling matter across the cosmos. But what if a handful of these ultra-high-energy particles aren't natural at all? Theory 27 proposes something extraordinary, that certain cosmic rays carry deliberate patterns, encrypted data beamed across the universe by beings who mastered the stars long before Earth formed. Take the infamous "Oh my God" particle detected over Utah in 1991. This single proton slammed into our atmosphere with the kinetic energy of a baseball traveling at 60 miles per hour, all compressed into a subatomic speck. The math behind its velocity is mind-bending. It was moving at 0.9999999999996 times the speed of light, so close to light speed that in its own reference frame, its journey across the universe would have felt instantaneous. But here's the kicker. Its trajectory points back to an eerily empty region of space, devoid of the kinds of extreme astrophysical objects that should produce such an energetic particle. Now consider the odds. For a proton to reach those energies naturally, it would need an accelerator of incomprehensible scale, something far beyond a supermassive black hole's capabilities. Yet alternative explanations are even more startling. Imagine an ancient civilization that built a cosmic ray generator the size of a solar system, using pulsars or magnetars as power sources, firing tightly focused particle beams encoded with information. The data wouldn't be in the particle itself, but in the statistical anomalies of its arrival, subtle timing patterns, energy fluctuations, or even the precise angles at which secondary particles scatter when it strikes our atmosphere. The smoking gun looked to recent anomalies in cosmic ray composition. Certain ultra-high energy particles arrive with trace elements of heavy isotopes, metals like platinum or uranium, that shouldn't survive such journeys intact. Even stranger are the clusters multiple cosmic rays hitting Earth in quick succession from the same patch of sky, with energies that form mathematical sequences resembling prime numbers or Fibonacci-like progressions. Skeptics argue these could be statistical flukes or artifacts of atmospheric interference, but proponents counter with a chilling observation. If you wanted to send a message across billions of years and light years, cosmic rays would be the perfect medium. Unlike radio signals that disperse and fade, or light that gets absorbed by dust, these particles barrel through galaxies unimpeded, their information preserved for eons. The most profound question isn't whether these patterns exist, but what they might be saying. Encryption schemes beyond our current math could turn cosmic rays into unbreakable one-time pads, their messages legible only to recipients with the right decryption keys. We might already have recorded these signals in particle detector arrays worldwide, mistaking them for cosmic noise. If true, the universe's first civilizations didn't leave behind ruins or radio waves. Their legacy is written in the violent impacts of particles older than our solar system, screaming silently through the dark, waiting for us to learn their language. We live in a universe of 3 spatial dimensions: length, width, and height. But what if the first civilizations discovered the keys to unlock higher ones? Theory 28 takes us into the mind-bending possibility of the dimension-hopping pioneers, beings who didn't just explore stars and planets but navigated the hidden layers of reality itself, leaving behind traces we've only begun to recognize. The math behind this isn't science fiction. String theory and M-theory suggest our universe might have up to 11 dimensions, most curled up so tightly we can't perceive them. But an advanced civilization could have developed technologies to unfurl or access these extra dimensions, using them as shortcuts through spacetime or as vast new realms for expansion. Imagine beings who didn't build cities on planets, but encoded their structures in higher dimensional space, rendering them invisible to our 3-dimensional perception, until we examine the subtle anomalies they left behind. One clue lies in Kaluza-Klein particles, hypothetical remnants of these extra dimensions. According to theoretical physics, particles moving through higher dimensions would appear in our 3D space as a series of nearly identical particles with increasing masses, like shadows cast by a single object from multiple angles. Strange particle detections in high-energy colliders, like the unexplained dips in certain energy spectra at facilities like CERN, could be echoes of these higher dimensional travelers. Mainstream physics attributes these anomalies to statistical noise or undiscovered natural particles. But another possibility lingers. What if they're artifacts of ancient technology, fragments of higher dimensional machinery briefly flickering into our perceptual plane? Even more compelling are the implications of brainworld models. The idea our universe might be a 3-dimensional brain floating in a higher dimensional bulk. If civilizations learn to navigate this bulk, they could bypass the speed of light limit by taking shortcuts through higher dimensions, the smoking gun. Unexplained gravitational anomalies, regions where gravity seems to leak away from our brain, as if something is tugging at spacetime from outside. Astronomers have detected peculiar voids where gravity behaves slightly weaker than predicted, and galactic clusters with lensing patterns that suggest hidden mass in places where no mass should exist. The most haunting question isn't whether higher dimensions exist, it's what we're missing. A civilization operating in 4 or 5 spatial dimensions would leave artifacts that appear impossible in our 3D world. objects that change shape inexplicably, structures with infinite internal volume but finite external size, or even shadows of their technology that seem to phase in and out of existence. We might already have recorded such phenomena dismissed as sensor glitches or optical illusions, when in reality, we're catching glimpses of a reality folded far deeper than we ever imagined. If the dimension-hopping pioneers succeeded, their legacy might not be in ruins or signals, but in the very geometry of spacetime, subtle wrinkles in the cosmos where dimensions intersect, waiting for us to develop the mathematical vision to see beyond the confines of our three-dimensional cage. And if we ever do, we might discover that the universe's first masters didn't vanish, they simply stepped sideways into realms we're only beginning to dream of. Pulsars, cosmic lighthouses spinning hundreds of times per second, beaming radio waves across the galaxy with clockwork precision. But what if these natural metronomes weren't just celestial oddities, but nodes in a vast, ancient communication network? Theory 29 unveils the Galactic Internet, a mind-bending concept where advanced civilizations repurposed pulsars and black holes into a universe-spanning messaging system, encoding data in the very heartbeat of the cosmos. At first glance, millisecond pulsars seem too perfect, their rotations so stable they rival atomic clocks, yet some exhibit peculiar anomalies. Take pulsar J0437-4715, a pulsar just 500 light-years away whose pulse arrivals deviate by nanoseconds in patterns that don't match standard glitch models. Or the Black Widow pulsar system, where timing irregularities align with orbital positions in ways that defy gravitational explanations. Mainstream astrophysics attributes these to unseen companion stars or crustal quakes. But another possibility lurks in the data. What if these deviations aren't noise but signals? Imagine a civilization facing the ultimate communication challenge: how to send messages across thousands of light years without signals degrading or requiring massive power. Their solution: hijack nature's most reliable radio transmitters. By subtly manipulating pulsar magnetospheres, perhaps using focused energy beams to alter their spin, they could encode information in pulse delays or phase shifts. A millisecond lag here, a microsecond advance there, spelling out binary or even quantum data in a language written not in words but in time itself. The beauty of this system is its durability. Pulsars last for eons, their signals piercing dust clouds and magnetic fields that would scramble conventional radio. The evidence grows stranger when you examine pulsar distributions. Certain regions, like the globular cluster Terzan 5, host improbable concentrations of millisecond pulsars arranged in near-geometric patterns. Even more provocative are their pulse profiles. Some show harmonic resonances, where multiple pulsars exhibit synchronized timing residuals as if locked into a network. The most striking example, the Pulsar Timing Array project, discovered a dozen pulsars whose spin rate fluctuations correlate over interstellar distances, a phenomenon astronomers call the gravitational wave background. But could it also be residual infrastructure from a dead civilization's comms grid, its nodes still faintly humming in unison? Black holes might serve as the network's relays. Recent studies of supermassive black holes like Sagittarius reveal unexplained quasi-periodic oscillations, fluctuations in their accretion disks that resemble signal modulation. If civilizations learn to ping black holes with precision energy beams, the resulting X-ray echoes could carry data across galactic voids. The math works. A black hole's event horizon could act as a quantum error-correcting surface, preserving information integrity over cosmic timescales. The implications rewrite our search for extraterrestrial intelligence. Instead of listening for radio whispers, we might need to decode the universe's own Morse code hidden in the ticks and tocks of dead stars. If we crack this cipher, the message won't be a greeting but a manual, instructions for accessing a library woven into spacetime itself, waiting for a species clever enough to read between the pulses. And if we're right, the cosmos isn't silent, it's screaming in a language of gravity and light, one we're only beginning to hear. Every civilization dreams of immortality, yet history whispers a darker truth. The 30th and final theory forces us to confront an unsettling paradox, that intelligence might carry the seeds of its own destruction. Meet the self-destructing architects, the idea that advanced societies don't fade quietly into the cosmic night but engineer their own demise, leaving behind not majestic ruins but eerie absences where greatness once thrived. Consider the ominous pattern on Earth. From Easter Island's ecological collapse to the Bronze Age's sudden unraveling, human history is littered with societies that outgrew their sustainability. Now scale this up to civilizations wielding godlike technologies, self-replicating nanomachines that reduce planets to gray goo, artificial superintelligences that misinterpret preservation commands as existential threats, or particle accelerator experiments that unwittingly trigger vacuum decay. The universe might be less a graveyard of dead civilizations than a gallery of abandoned canvases, each bearing the half-finished strokes of artists who erased themselves before completing their masterpieces. The smoking guns, they could be all around us. Take Tabby's star again. Its erratic dimming might not be Dyson spheres under construction, but their catastrophic failure, megastructures crumbling after a civilization lost control of its own energy-harvesting swarm. Or consider the Fermi bubble's gigantic gamma-ray structures ballooning from the Milky Way's core. Astronomy attributes these to ancient black hole activity, but another possibility lingers: the radioactive scars of a long-ago war fought with antimatter weapons, a conflict so total it sterilized the galactic center. Even Earth's own asteroid belt takes on new menace. What if it's not the remains of a failed planet, but the rubble of a world disassembled by runaway mining bots, their programming corrupted over millennia? But there's a flip side to this doom. The Great Filter Hypothesis offers a sliver of hope. Perhaps these catastrophes aren't inevitable, just rites of passage that a lucky few civilizations survive. The absence of galactic empires might not mean everyone fails, but that those who succeed transcend into forms we can't yet perceive. Maybe the ruins we're searching for aren't silent because their builders died, but because they graduated to something beyond ruins entirely. The ultimate question isn't whether civilizations self-destruct. It's whether destruction is the end or just another beginning. Across billions of years and galaxies, intelligence might rise and fall in cycles, each collapse leaving behind not just warnings but lessons. And if that's true, the most valuable artifact we could unearth wouldn't be some ancient machine or message, but the records of their final moments, the autopsy reports of gods waiting to teach us how to avoid their fate. From quantum archaeologists encoding their history in the vibrations of subatomic particles to dark matter architects building invisible cities woven into the fabric of spacetime, these 30 theories don't just rewrite cosmic history, they shatter our understanding of what's possible. Imagine civilizations so advanced they didn't just harness stars but reprogram them like celestial computers, or societies that escaped entropy's grip by bending time itself backward in isolated pockets of the universe. These aren't just wild speculations, they're hypotheses grounded in cutting-edge physics, forcing us to confront the unnerving idea that everything we think we know about life, time, and reality might be a tiny footnote in a story that began billions of years before Earth formed. The sheer scale of these ideas is humbling. We're used to thinking of human history in terms of millennia, but the universe operates on a canvas stretching back 13.8 billion years. In that incomprehensible span, entire civilizations could have risen, mastered technologies beyond our wildest dreams, and vanished, leaving behind echoes we're only now learning to detect. The cosmic microwave background might hold their fingerprints. The gravitational waves rippling through space could carry their messages. Even the empty voids between galaxies might not be empty at all, but the carefully curated work of beings who treated reality itself as their playground. What's truly thrilling is that we're living in the era where these theories transition from sci-fi fantasy to legitimate science. Telescopes like JWST peer deeper into the past than ever before, while quantum computers and AI give us tools to decode potential patterns hidden in the noise of the cosmos. Every anomalous star, every unexplained particle, every bizarre gravitational signal could be a clue, a fragment of a puzzle we're only beginning to assemble. The universe isn't just old, it's layered with secrets, and we're the first generation with the technology to start peeling back those layers. So here's the real question: which of these theories left you staring at the screen, questioning everything? Was it the Boltzmann brains, the possibility that you might be a fleeting quantum fluctuation hallucinating an entire existence? The holographic ancestors who coded our universe into existence like cosmic software engineers? Or the silent watchers, those eerie overseers who might be observing us right now from the shadows, enforcing their version of a galactic prime directive? Drop your mind-blown reactions in the comments, and whatever you do, stay curious, because the wildest truth of all might still be out there, waiting to be uncovered in the next flicker of a pulsar, the next whisper of a neutrino, or the next great leap of human imagination. The cosmos is stranger than we've dared to guess, and the adventure is just beginning.